All right, good morning, Tigers. This is your video for lesson 2.1. We are officially starting solving equations. So this is kind of the heart of algebra. Like if you don't, this sounds so negative. If you don't get this, you're going to struggle this year. So really pay attention, take good notes. Now when I say if you don't get this like right away, that's fine. Keep practicing. But if you don't get it and don't make an attempt to get better, you're going to struggle this year. So this is, and I'm not saying that to scare anybody, I just want to place the importance of this lesson. This whole little, like lesson 2.1 through 2.5 is kind of the heart of algebra. If you can do this, you can kind of figure everything else out. So we are, some of you will be watching this at home. Some of you will be watching this in school. I think you know, I don't really know what day we're on at this point. Remember, I'm recording these kind of early. So just make sure you're taking good notes. Make sure you have your copy of the notes with you. And let's go ahead and get started. Okay, so let's annotate our learning targets so we know what our end goals are. We're going to use units to understand and interpret problems. We're going to choose and interpret an appropriate scale for a graph. These two we did in the last section too, so those should be familiar. We can explain each step when solving an equation. We can construct a viable argument for choosing a solution method. So that sounds like a bunch of nonsense. Basically what it's saying is you can make a point, like you can argue, hey, I solved it this way because, and it makes sense. You can tell me, you know, we're going to have multiple ways of solving different equations, but if you can say, hey, I did it this way because blah, 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 and that's what this means, is that you can argue why you picked that method. Argue correctly, let's say it that way, because everybody can argue. We can solve a linear equation in one variable, and that's kind of the heart of this whole lesson. And then I can solve a literal equation. This will come into play in lesson 2.5. So we won't be doing that today, but we're going to get to it. Okay, you have your correlating learning tasks. This is a little out of date, so I'll have this will be more up to date on your copy with the guided video, it should be assignment 2, and then the correct spiral review. Okay, and then we have our vocabulary. So I'll let you look through that, and let's go ahead and get started. So task 1, we are going to be writing and analyzing equations. Okay, so I'm going to ask that you try 1 and 2. When it says, let's play what's my number, determine using the clue, this is your clue. So, this little piece. So, I'm going to let you answer 1 and 2, and I will post my answers in a minute. So, go ahead, pause the video, and give yourself a second to try to figure this out. Okay, so let's kind of go over what I've done. So, let's play what's my number. If you multiply me by 3 and increase that value by 5, I am 20. What's my number? You should get 5. So 5 times 3 is 15. 15 plus 5 is 20. What I did, I used inverse operations. I just came up here and said, okay, something times 3 plus 5 is 20. So if I subtract the 5, we get down to 15. And if I divide by 3, we get down to 5. And then I'm just left with that something. And that would be 5. There are a lot of different ways you could approach this. I know in the past people have done guess and check. People have done, have written an equation like I did in number 2. There's a couple of different ways to approach this, but you should get 5 as your answer. All right, so number 2, one of the ways you could have figured it out is by writing the equation, blah, blah, blah. So something times 3. So we're going to have x be our something, or x is the number I'm looking for. One of the things we always want to do is state what our variable is and what it represents. That's going to help you when you get to word problems. It's going to be a lifesaver. Okay, so something times 3 plus 5 equals 20. And that's my equation. Something times 3 plus 5 equals 20. And then you can solve that if you'd like, but we're going to get to that in a minute. All right, so we're going to do number 3 together. Number 3 is not hard, but like I can see where people would get kind of frustrated with this. So what we're doing is I want you to see how equations are built so that when you go to solve them, you see what you're undoing. Okay, we're looking at doing and undoing. And that's basically what solving an equation is getting rid of all the junk to where you're just left with your variable and what that variable is equal to. Okay, so what we're going to do is we start with x equals 4. Boom. Our next step, we want to multiply both sides by 5. So if I do 5 times x, I get 5x. Well, if I multiply the left side, it's like a scale. If you want something to one side, you got to do it to the other. So if I multiply this number by 5, my scale goes to where this is heavier and this is lighter. So to even it back out, I have to multiply this side by 5. Hope that makes sense. So if I multiply x by 5, I get 5x. So if I multiply 4 times 5, well, what do I get? 4 times 5 is 20. Okay? So the next thing says subtract 13 from each side. So this becomes 5x minus 13. So I subtracted 13 from this side. Now notice I can't combine these. I won't get a negative number or anything because I don't know. On this side, we're assuming we don't know what x is. Now we know what x is because we defined it, but I can't take 13 from 5x. In order to subtract, they would each have to have an x. That's called combining like terms, which you should have a little bit of experience from in 8th grade. So if we subtract 13 from the left side, we have 5x minus 13. If I subtract it from the right side, well, 20 minus 13 should be 7. So now this is how all your math teachers build equations for you to solve. We start with the answer and then do math on either side until we have an equation. So our equation is 5x minus 13 equals 7. And so we did things to both sides of the equation to get this, and then so to solve, we're going to have to undo all those things we just did. And we'll get to that in a little bit. So I want you to try number 4. So number 4 is just like number 3, except you're going to choose what you want x to equal. So you pick a number for x. And we'll just put for operation, start with x equals, and then whatever number you choose. Okay? I want you to have at least 2 steps. So I need you to have at least these 2 boxes filled. Okay, these 2 lines filled. If you want to continue, go for it. Have fun with it. This is kind of a little creative. But if you just want to do 2, that's fine. So I'm going to ask that you pause the video and try this on your own. Now, just to be clear, I am going to, while the video is paused or while you're pausing yours, I'm going to be working on one and I'm going to create an example. When I check these or when I look at these, I want you to have something other than my example because I want you to try it on your own, okay? So go ahead, pause the video, and come up with something fun for you to do, some sort of equation for you. Okay, so I had fun with mine. Mine looks a lot scarier than most of yours will because I wanted to show you one of each operation. So I started with x equals negative 3. If I add 10 to each side, I get 7, and then multiply both sides by 2, and then subtract 4 from each side, and then divide each side by 5. So yeah, that looks like so much fun to solve, right? We'll get to solving stuff like this. This is why I wanted you to have a different example from me, because you're going to have to solve whichever one you created. So yeah, hopefully you didn't go as ugly as mine is. I had fun with it, but that's just me. Okay, so let's go on to the next page. Okay, and we're going to do, let's see, we're going to do 5 together, and then I'm going to let you do 6 on your own. So we're just going to analyze what is happening to x here. All right, so consider the equation 15x plus 8 equals 68. Describe the 2 operations that are being done to x. So if I look at this, what am I doing to x? So let's look at x. What's the first thing that you notice? X is being multiplied by 15. So we're going to write that down. Okay, x is multiplied by 15. Okay, so then, and we want to start, because I have a lot of people go, well, which one comes first, the multiplication or the addition? I always say start with what's closest to x, because as you build your equation, things get farther and farther out. So if we want to analyze the order that they happen in, let's look at what's happening, what's closest to x, and kind of analyze out. So the first thing that I noticed, like the closest thing to x is that 15. So the first thing that's happening is it's multiplied by 15. After that, look, we have this 8 and a plus sign. So that means we added 8 to the 15x. So we multiplied by 15, then added 8. Okay, that's all I want you to do for number 6. So number 6, you should have 3 things that are happening. Okay, start with what's closest to x and move yourself out. I'm going to pause it, or you pause the video, give yourself a few minutes to try it, and then you can check your work. Okay, so let's look and see what we've done. So the first thing I noticed, I find my x. First thing that happens is I've subtracted 3 from it. Perfect. Okay, then what happens? Well, I've subtracted 3. Then I divided by 4. So if you look, a lot of people are like, well, is 2 closer or is 4 closer? That makes a fraction. They're kind of close together. So we subtracted 3, then we divided by 4, and then we added 2. Perfect. There we go. Okay. So let's look at task 2. So that's just writing equations and kind of analyzing them, see what's happening. So now we're going to look at what does it mean to have a solution for an equation. So let's look at the definition of solution. A solution is any value that makes an equation true when substituted for the variable. So if I take a number and put it in for x or n or whatever my variable is, and the equation comes out to be a true statement, then we know it's a solution. Okay, so let's try this. So we are given, for 7, we're given some values for x, and we're asked to determine whether or not it's a solution. Okay, so let's take x equals 2, and we're going to substitute it in for x. So I'm going to use 2 different colors because I think when I substitute, it's easier to see what I'm actually doing if I do 2 colors. So I'm going to rewrite the equation, 2 plus 4, and instead of x, I'm going to substitute the 2. So we have 2, and then minus 1 equals 22. All right, so now we want to make sure we follow our order of operations. So if you don't remember, we start with what's in parentheses, any exponent, do any multiplication or division, do any addition or subtraction. Remember, multiplication and division are interchangeable. They're inverses, so you can multiply first or divide by first. It's either one, which depending on the order they're found here. Okay, so let's take care of parentheses first. We have a 2 minus 1. 2 minus 1 is 1. Okay. So then we don't have any exponents, but we do have some multiplication. We have 4 times 1, which is 4. Okay. And then let's add 2 plus 4 is 6. So we have the statement 6 equals 22. Now, when we're asking is it a true statement, are 6 and 22 equal? Well, no. If your paycheck is supposed to be $22 and I only give you 6, you're probably going to be mad at me. So we know this isn't a true statement. So when we look at this, we're going to say 2 is not a solution. Because when we substituted 2 in for x, we came up with a statement that's not true. So I'm going to put not true here. Okay, so I'm going to ask that you try B and C. So go ahead, pause the video, and give yourself a minute to try B and C. Okay, so I hope you took some time to pause your video and try this. I'm going to skip B and C. I don't want this video to get extremely long. And remember, I don't want this to just be okay, I'll mute her and copy everything. So you can find these on the keys online, but you'll only find the answer. So I want you to make sure that you actually plugged it in and tried it. Okay? All right, so let's move on. I'm also going to ask that you pause the video again and try both 8 and 9. So some quick, so something to help you. Remember, this is the equation from item 3 on the first page. So you already have the answer. So you want the final equation, okay? And so actually, I'll go ahead and start that for you. So if I look at item 3, the final equation was 5x minus 13 equals 7. So that's from here, okay? So we're going to use inverse operations to solve this. I want you to try 8 and 9. I'll come back and have it worked out, but go ahead, pause the video. You try this one on your own. Okay, so yours should look similar to mine. So the equation from item 3, we ended up with 5x minus 13 equals 7. So we want to know, here's my operation. 13 was subtracted from both sides. That was the last thing we did, was we subtracted 13 from both sides. So my inverse from that is to add 13 to each side. So if I do that, negative 13 and positive 13 cancel. 7 plus 13 is 20. So you end up with 5x equals 20. Okay, then the next thing I did, or the first thing I did, was that both sides were multiplied by 5. So now I'm going to divide by 5 to cancel that out. So we divide by 5, we're left with x equals 4, which is our solution, which makes sense because when we wrote the equation, we started with x equals 4. And then we wrote our equation. And we built it, and then we did the opposite. We did the inverse of that to get back to our solution of x equals 4. Okay. So, number 9, what did you notice about the order of operations in the table above compared to the table in item 3? So, when we did this, we said, okay, first thing we did was multiply both sides by 5, then subtract 13. Well, then we went from the equation to minus 13 to multiply by 5. These were backwards. And if you think about it, when you, let's say you're wrapping presents. This is always my favorite go-to. When you wrap presents, you start with your present, then you put it in the box, and then you do your wrapping paper, and then you do your ribbon, and then you do your bow, or however you do it. I know not all of us are that fancy, me included. But then when you go to open it, you can't just go straight for the present. You have to undo the bow, then undo the ribbon, then take off the wrapping paper, then open the box. You have to do you have to go in reverse order. So when you wrap your present one way, and when you unwrap it, you go backwards. It's the same with solving equations. You do the opposite of what you did to build your equation. Okay, so why do you think that the order is the way it is? Basically, you're undoing it. So whatever was done, you have to go backwards and undo. So there you go. All right. So let's look at this undo list. I will be the first to admit, like when I typed it, I did it one way, but when I write it by hand, I do it another way. So we're going to look at this equation right here, or this equation. This is solving, this is the actual equation. So this is an undo list is a way of helping you solve equations. I will tell you personally, like, I don't use an undo list, but I've also been doing algebra for 15 years now, since I was a freshman. So I don't typically use an undo list, and you may not need to, but I want you to start using them so you can see the connections, like, okay, this is why I'm doing this. I'm actually trying to undo this. So I'll use an undo list for a couple of weeks, and then I'm probably going to move away from it, and that's okay. You can use it all year if you want to. I know some people aren't math people and they don't see it right away. So this is a tool to help those of you that need it. I would prefer that everybody start off using this, and then not everybody's going to need to do it for the rest of the year, but some people will, and that's okay. That's why you have this. I'm not going to give you something and then say, oh, you can't use it anymore. Okay, so let's look at what an undo list is. So basically, we've kind of started creating these without actually putting them in this form. So what we're going to do is we're going to look and analyze what's being done to x. So what's the first thing being done to x? Oh, x is being multiplied by 12. Okay, so we've got the 12x. Then what did we do? Well, we've added 4. And then the last thing we did was divide by 7. So if I want to undo this, we're going to start from the bottom and work our way backwards. So since the last thing we did was divide by 7, the first thing we need to do is multiply by 7 to undo. So let's look over here. So here's our equation. First thing we're going to do is multiply both sides by 7. What's going to happen is the 7's will cancel because we're undoing the division. And then 4 times 7 is 28. We're undoing the division on this side. We just don't see it on this side. So we're going to multiply 4 and 7, get 28. So boom, this is where we're at. Okay. Then we had 4 was added to 12x. So to undo adding 4, we're going to subtract 4. So this positive 4 and negative 4 cancel. 28 minus 4 is 24. So this is where we're at. Okay, we undid adding 4 to each side. So the last thing we have is x is multiplied by 12. So to undo multiplication, we're going to divide by 12. So 12 divided by 12 cancels, and you're left with just x. 24 divided by 12 leaves you with 2. So we are down to just our variable is equal to a number. And there we go. So we have solved our equation. So this was our first equation that we've solved. So all we did was we took our steps and undid them. All right. So if you follow this, you're doing this, and then to undo, you're going back up. Now I'm going to show you on the next one how I write it, and you can write it either way. It'll be fine. So it's just another way of visualizing it. So I'm going to do on number 10, I'm going to do the first one. I'll show you how I write my undo list. And you can use either format. And then and then I'm going to have you do 10 and 11. Now, well, we'll get to that. We'll get to 11 in a second. All right, so let's start with number 10. We want to use an undo list. So let's look. What's the first thing that I am doing to x? Well, the closest thing to it is the negative 5. So the first thing we're doing is multiply by negative 5. Okay, and you don't have a lot of room, so you can abbreviate. You just need to know, oh, I multiplied by negative 5. Okay, and then the next thing we did was subtract 6. Okay, so then I want to do my undo list. So if you notice on this one, we lined them up on how to undo it, and we went down and back up. I sometimes find that confusing, so what I'll do is I'll start with my last step and put it at the top. So to undo subtracting by 6, I'm going to add 6. Okay? And then to undo multiplying by negative 5, I'm going to divide by. negative 5. So you can either go down and up, or you can just draw an arrow and then bring it down. If you had more steps, I would just go in backwards order and write them down. So they won't line up across, but for people who like to read from top down on what they need to do, here you go. Okay, so let's actually do this. I'm going to do this to the side because it didn't really leave us a lot of room. Okay, so the first thing I'm going to do to undo subtraction, we're going to add 6 to each side. These will cancel, and we're left with negative 5x equals 7. Okay, then I want to divide by negative 5 on each side. These will cancel, and x equals 7 over negative 5. You can leave it like this. A lot of people will see a fraction and be like, ooh, let me put that in the decimal. You're going to find that as you advance in math, fractions are a lot easier to work with. We don't need to do anything with that. We can leave it as is. Something else that's worth noting. A lot of people will say this is positive 7 over negative 5, which is fine. I want you to know, though, that negative 7 over 5 is the exact same answer. Because if you were to do it as a decimal, this would be like 1.4 or something, negative 1.4, and the whole number is negative. You can also say x is equal to negative 7/5. So the negative can be on top, on bottom, or in line with a fraction bar. I typically put my negative on top, even if I divided by a negative number. It just is visually more pleasing to me. The only thing I will say, if you do negative 7 over negative 5, the negatives cancel and it's positive. So you don't want a negative in both, but it doesn't matter if the negative's with the 7, with the 5, or right by the fraction bar. They're all the same thing. Okay, so my solution is going to be that x equals negative 7/5. Okay, so I want you to use an undo list to solve number 10. And then number 11, you're going to use an undo list to solve the equation you wrote in item 4. So if we go back, I want you to look at your number 4. This is why I wanted you to have something different from me, because if that's not going to be pretty to solve. It's not going to be terrible because you actually know what your solution should be. But so if you want to go ahead and put not if you want to. When you go to solve this, you need to put your final equation down, put it right here, and tell me what you did, and then do your undo. And you already have all your do's because that's what this column was. So that should not be too terrible for you. So I'm going to ask that you pause the video. You do your undo list for the second part of number 10 and for number 11. Okay, so I just wanted to let you check your do and undo list. So the first thing I did was divide by 4, and then I added 7. So to undo that, I'm going to subtract 7 and multiply by 4. I did the math here. It's kind of messy, but after you subtract 7, 12 minus 7 is 5. 5 times 4 is 20. So there we go. All right, so the undo list for yours. So yours should look different from mine, but I'm just going to show you how I did mine to show you it's even as scary as this one looks, it wasn't terrible. So the first thing we did, and remember, you can go check your notes from the very first page if you want to double check yourself. First thing I did to x was add 10, then multiply by 2. Subtract 4, divide by 5. Got that list here. So to undo dividing by 5, we multiply by 5. To undo subtracting by 4, we add 4. To undo multiplying by 2, we divide by 2. To undo adding 10, we subtract 10. And I actually subtracted over here. I just wrote add. So let's fix that. All right, so over here, I rewrote my equation in blue. First thing we did was multiply both sides by 5. 5's cancel. 2 times 5 is 10. Add 4. 4's cancel. 2x plus 10 is 14. Divide both sides by 2, the 2's cancel, and you're left with x plus 10 is 7. Subtract the 10, and you're left with x equals -3, which is what I started with. So, there we go. I know that was a lot of work. And again, yours should look different. You should, as long as when you undo everything, you get back what you started with, you know you've done it correctly. Okay, so number 12. The best part about algebra is that you can always check your own work. So take the solution you get from x, for x, and substitute it into the original equation. If you have a true statement, then you've solved it correctly. So on the solving equations quiz, there really is no reason for you to get any of them wrong, because after you solve it, you can take your solution, plug it in, and make sure you did it correctly. And if you get something that's not true, then you know, okay, I need to go back and fix something. So everybody should get a 100 on their solving equations test because you can check your work. Okay, so we'll do these together. So we're going to take our equations. So our first equation on number 10 was 5x minus 6 equals 1. And my solution for that was x equals -7 over 5. Okay, so this sounds like it's going to be hard to work, but it's actually not going to be terrible. All right, our second one is x divided by 4 plus 7 equals 12. Okay, and we've got a solution of x equals 20. Again, it looks difficult, but it shouldn't be too bad. And then I want you to check your own answer. I'm not going to do mine, but I want you to check your own for 11. Okay, so let's look at this. I'm already going to tell you, I know a lot of people are freaking out because they're like, oh my gosh, I can't math with fractions. There are some easy tips and tricks to do with these, okay? And we'll figure that out. We're going to do this together. So let's go ahead and start. We're going to plug in, for x, I'm going to plug in -7/5. Every time I plug in, I always use parentheses. If you don't, this could look like 5 minus 7/5 instead of 5 times -7/5. It makes your math look a lot easier and a lot nicer and neater. Okay, so let's start simplifying. If I look, this is -5 times -7/5. Well, what's going to happen is if you have something, this is 7 divided by 5. Well, dividing and multiplying are inverse. So dividing and multiplying 5 cancel out. So now we have no fraction. Yay! Even better, a negative times a negative is a positive. So this becomes, the negatives cancel. So this becomes just a positive 7. And 7 minus 6 equals 1. Is that a true statement? Well, 7 minus 6 is 1. We get 1 is equal to 1. So it's a true statement. So x equals -7/5 was the correct answer. Yay! We did it right. Okay, let's try this one. We're going to plug 20 in over 4 plus 7 equals 12. So we're substituting the x with the 20 that we got over here. We're going to just check to see that we did this right. So I know people, again, oh, it's a fraction. Well, can we divide 20 by 4 evenly? 20 divided by 4 is 5. So now we have 5 plus 7 is equal to 12. Okay, what's 5 plus 7? 12. So we have 12 is equal to 12. Is that a true statement? Yay! We did this one right too. So I love it. You've got a built-in check yourself system. Go ahead and pause the video and try to do number 11 on your own. Not number 11, try to check your number 11 on your own. Okay, so again, hope you paused the video to do number 11, or just check your number 11. So we're going to go ahead and move on to task 3. Again, because my equation is different from what you have, I'm not going to check mine. I already know it's right. I've done it before. Okay, so task number 3, properties of equality. So there was a video that you should have watched prior to this one that kind of basically went over the properties of equality. I'll go through them really quickly, and we're going to use them to justify steps. Basically what the properties of equality are it's when you get into geometry, and I know this is Algebra 1, you're not thinking that far ahead, but when you get into geometry, you'll have these things called proofs. And basically you have to prove that something is true about a certain figure, or that something's true about 2 angles. You'll have to prove that the Pythagorean theorem works every single time. There's a reason I teach algebra and not geometry. I'm not a big proof fan. Algebraic proofs are way simpler. And basically it's just saying, hey, this is true because I can do this. These are your reasons that, hey, I'm allowed to add something to both sides because of the addition property of equality. Things will stay equal. So this is me giving you permission to play with equations. This is me giving you permission to add or subtract or multiply or divide from each side. So the way I like to think of it is your equation is like a scale. And you want your scale to stay equal. Okay, well what happens if I add weight to this side? If I add weight, this side's going to sink down and this side's going to lift up. So they're no longer equal. So if I add something to this side to keep them level, I have to add to this side too, and that brings them back to the same level. If I subtract something from the left side, it's going to shoot up, this is going to fall down. So if I want to keep it equal, I have to subtract from this side too. So they have to stay equal. What you do to the left side of your equation, you have to do to the right side if you want it to stay equal. Now there are some exceptions to this. Like if I have like a 3 plus 4 plus x equals 12. Well, if I combine the 3 and 4 in this side, that's just combining like terms. That's not taking or adding, or that's not introducing something new to that equation. That's just grouping. So there are a few things, but for the most part, like if I introduce a new number and add or subtract or multiply on this side, I have to do the same thing to this side too. So our addition property of equality, if I have 2 things that are equal, I can add the same number to each side. Subtraction, same thing, except I can subtract the same number from each side. Multiplication, if I have 2 things that are equal, I can multiply by the same thing. Division, if I have 2 things that are equal, I can divide by the same thing, except 0. So C cannot equal 0 here. And if you're kind of confused, like why can't I divide by 0? If you have 10 cookies and you want to put them into groups of 0, can you do it? Well, no, 'cause you'd have to somehow get rid of your cookies. Now, I know some of you smart ones are going to be like, well, just eat the cookies. That doesn't work. You get a pile of cookies in your tummy. It doesn't work. And then later that pile goes somewhere else. So they still exist. You can't just take something and make it not exist anymore. The mass will always be there. So you can't take a group of something and then put it into groups of 0. It does not work. When you try to do this in your calculator, anytime you do something divided by 0, you'll get a big fat ugly error. Okay, some other important properties. Symmetric property. If A equals B, then B equals A. Basically, so what this tells me is if I get like 4 equals X, and I don't like to have X on the right side because I'm OCD, I can swap it and say X equals 4, and it's the same thing. All right, these are kind of the ones that are probably a little more important. These are kind of self-explanatory. These are a little more important. Commutative property means that I can add A and B, or I can add B and A and get the same thing. It doesn't matter. 3 plus 4 and 4 plus 3 are the exact same thing. 3 times 4 and 4 times 3 are the exact same thing. So this just tells me what order I add or multiply in gives me the same thing. But notice it says addition and multiplication. If you subtract in a different order, your answer will be different. If you divide in a different order, your answer will be different. 3 divided by 4 is not the same thing as 4 divided by 3. Think about it, if you have 3 cookies and 4 people, everybody gets 3/4 of a cookie. If you have 4 cookies and 3 people, everybody gets 1 1/3. So there's a difference. There's a difference there. Same with subtraction. If I have $10 and spend 5, I have 5 left over. If I have $5 and spend 10, I owe somebody money. So it only works for addition and multiplication. Same with associative property. Associative property just tells me that, hey, I can add A plus B first, or I can add B and C first, and I'll get the same answer. Same with multiplication. I can do A times B times C, or do B times C and then A. I'll get the same thing. These come in handy when you have lots of terms to add or multiply, and like if you're like me, I like to group them into easier sets. Like I try to add things that'll equal 10 and try to add things that, you know, in certain order so that they're easier to do in my head. And then the distributive property. This is one of the most important properties we'll use. If you have a B plus C in parentheses, you can multiply both B and C by A. And you can have A times B plus A times C. If it's all numbers and no variables, you can add the 2 things in parentheses and then multiply. It's completely up to you. It's just saying that, yes, I can multiply both of these numbers by that number and get the same answer. Okay. And what we're going to do is we're going to start analyzing equations and seeing, oh, what did they do? What did they do here? So we're going to do that in 13. You have an example here. Basically, you start with your original equation. Sometimes you'll see the word given here. It's the equation that's given to you that you started with. And then it's just, well, how did they get from this step to this step? Well, the only thing different is we swapped the 90 and the 2x. That's the commutative property. How did we get from here to here? Well, they added the 3x and 2x. We combined like terms. So we're not even solving here. We're just stating what is being done. So let's do that. Let's try that. Okay, so let's look at what's happening here. We have our equation, 5x plus 15 equals 0. That was given to us. So now let's look at what's different between here and here. Well, I have a minus 15 here and a minus 15 here. So what did I do to get from here to here? Well, I'm subtracting 15 on either side of the equal sign, on both sides of the equation. So if I go back to my property list, what tells me that I can subtract from both sides? And that's the subtraction property of equality. So we'll write that here. And I abbreviate as POE because it's a lot to write. Okay, so now let's look what's different from here to here. Well, we did 15 minus 15, and then we did 0 minus 15. So even though it feels like, okay, well, we subtracted 15, this is a subtracting. Here we're combining our like terms. So here we're writing the subtraction. Here we're actually doing it. So this is combine like terms. Sometimes you'll also see the word simplify here. I think combine like terms is more accurate. Simplify is used a lot more when you actually divide or multiply, but you are simplifying though. All right, so let's look at from here to here. What did we do to get from here to here? So if I look, the difference is I have divided by 5 and divided by 5. Remember, fraction bars mean division. So I divided both sides. What allows me to do that? The division property of equality. Okay, so how did I get from here to here? Well, the 5 divided by 5 cancels. Negative 15 divided by 5 is negative 3, so I'm actually doing the division. It's not combining like terms because we're not adding, or we're not actually combining. We are actually just simplifying here. So we can write simplify. And our solution is x equals negative 3. so let's move on to the next page. Okay, so 14 and 15. I'm going to ask that you pause the video and you try these on your own. So good luck. Alright, so I'm going to explain my thought process on these. Just be aware, there are actually several different ways that you could choose to do this. If you made a do and undo list, that probably helps you out a lot. So let's start with the first one. So the very first thing I did, I noticed I had a 12D and a negative 3D, and I combined those. So what you may have done is maybe you subtracted the 2 first and brought it over here and then combined. You want to make sure that you do combine those like terms so that you only have one variable to work with and you're not trying to solve for 2 different variables. So you could have swapped the order of these and that would still be fine. Because they're all, again, it's the commutative property, it's all addition and subtraction. Okay, so we have 12D and negative 3D, and that gave us 9D plus 2. So I combined my like terms first. Then I subtracted 2 from each side, that's the subtraction property. Okay, then I divided both sides by 9, that's the division property. Now over to the side, 3 divided by 9, that becomes the fraction 3/9. Now I'm okay with improper fractions, like if you had like 5 over 4 or something, but we do need to keep this as simple as possible. And again, I know that sounds like it's a headache, but when you go to plug these back in and solve, it makes your life a little bit easier. So 3 divided by 9, we can divide both the top and bottom by 3 and get 1/3. So we get D is equal to 1/3. We've simplified it. Okay, number 15. Again, I'm going to show you a neat trick with fractions here, which is why I did it this way. Again, I know a lot of people are like, fractions, I can't, but there are some tricks to help you. All right, so we have our equation that was given to us. The first thing I did was I took the negative 12 plus 8, combined them to get negative 4, so combined like terms. Added the 4 to either side, that's the addition property. Then we get here, 12 equals 3 over 2 times x. Okay, so this is something, let me get a little scrap of paper real quick. So we have 12 equals 3/2 x. So I'm taking the fraction 3 over 2 and multiplying it by x. So we want to divide by 3 over 2, okay? So I don't know if you remember what to do with fractions, but when you divide fractions, you are actually multiplying by the reciprocal. And what's neat is that you can cross cancel or cross reduce. So the 3 and 3 cancel and the 2 and 2 cancel. So instead of trying to divide by a fraction or convert it to a decimal, or you could have also multiplied both sides by 2. That would have been 24, and the 2's would cancel, and that would be equals 3x, and then divide both sides by 3, and that would give you x equals 8. You could do that. That's 2 steps. Or you can just multiply by 2/3. It's the same thing. You're still multiplying by 2 and dividing by 3, but this cross cancels and it becomes 1 step. So if you were trying to divide by a fraction, multiply by the reciprocal. And if you do that, the 2's cancel, then the 3's cancel. And then come over here. We're going to do 2 times 12 is 24, then divided by 3 is 8. So you can step it out. You can do it in 2 steps, and that's fine. If you choose to do that and that makes more sense to you, do that. I don't care. Do whatever makes more sense to you. As long as whatever you do is mathematically legal, I don't mind if you multiply then divide, or divide then multiply, or you multiply by the reciprocal. Whatever makes the most sense to you, do it. As long as you're not pulling numbers out of your butt. Okay, so I multiplied by 2/3. So 2 times 12 is 24, divided by 3 is 8. Or I actually divide first so that I have smaller numbers. So 12 divided by 3 is 4, times 2 is 8. And it works out. Okay. All right, so let's look. We're going on to task 4. I'm going to do the majority of this with you. I'm going to set it up for you, and then I'm going to let you kind of work it out on your own. All right, so we are writing, solving, and interpreting an equation. Okay, so Kirk has $5 more than Jane. Together, Kirk and Jane have $19. How much money does each person have? So we just want to figure out how much money does Kirk have, how much money does Jane have. So we're going to start writing an equation. We're going to let J represent the amount of money in dollars that Jane has. So we're going to write to the side, J is Jane's money. You always want to say this is what this variable means, especially when we get to 19. Okay, so J is Jane's money. We want to write an expression for Kirk's money. We don't want to throw another variable in. We don't want to say J is Jane's, K is Kirk's, because we don't know how to solve an equation that has 2 variables yet. We only know how to solve it if it has 1. So let's compare. What do we know about Kirk's money? Well, Kirk has $5 more than Jane. So Kirk has Jane's money plus 5. Okay? So this is Kirk's money. This is Jane's money. So we want to write an equation to represent the situation. So we know that if we add Kirk and Jane, we should get 19. So remember, Kirk has J plus $5. And then Jane has J dollars. So remember, this bubble is Kirk and this is Jane. So Kirk plus Jane is a total of $19. Okay, so in a minute I'm going to ask you to work 18. Let's talk about 20 because I'm going to let you work the rest of this. Let's talk about 19. 19 says interpret your solution to item 18. So what you're going to get is J equals something, and then you're going to check it. So you're going to solve, and then you're going to check, and you're going to have J equals something. So when it says interpret, what does that J equals mean? So this is when we go back to, well, what did J stand for? J is Jane's money. So when we get J equals blank, that tells me that Jane has blank dollars. So that's what interpreting means. Interpreting your solution is one of the biggest things you can do. And I don't mean to be like, oh, because it's going to be on the leap, but really and truly, if I gave you a problem, I probably don't want to just know a random number. Like when you get into the workforce or the real world and your boss tells you he needs something solved, it's because it has a context to it. That your equation might be something to do with the number of boxes that you can get on your shipping truck now that they've increased the size, or or I'm just trying to think of real world things. Once you I lost my train of thought. Once you get in the real world, all your problems, there's a reason for them. And so that's why you need to interpret. I need to know, what does this J equals blah, blah, blah mean? Well, it means that's how much money Jane has. That's why we define our variables. That's why we put that J means this, or X means this, or R means this. It's so that we know what we're solving for and we can interpret it. So after you solve and check, you should tell me that J equals blank means that Jane has blank dollars. Okay, and then number 20 says verify the reasonableness of your solution by checking that your answer to 19 matches the information in the given problem. So if for some reason you have that Jane has negative money and Kirk has like $50, does that make sense? Well, no, because together they have 19. I shouldn't see Jane having negative dollars. I shouldn't see Kirk having more than $19. Because you can't, that wouldn't really make sense. So we want to double check and make sure that our information matches what we were given. We want to make sure that Kirk has, when we get our solution, Kirk has $5 more than Jane. and we want to make sure that their total is $19. We just want to make sure that it makes sense. If for some reason you get Kirk has $50, that should be a red flag. Like, wait a minute, they only have 19 together. He can't have $50. That doesn't make sense. So that's what verify the reasonableness is. If you can handle that, if you can make sure that your answers make sense, you're going to be a little bit ahead of other people, because some people will just give me random numbers and I'm like, that's not even a possibility if you read the problem. So I'm going to leave this here. This is already almost an hour long. So I'm going to stop here. I'm going to ask that you finish this. Again, the answers will be on the key, so you can double check your work. Thank you so much for your attention. I know this was a long video, but this was a long lesson. So I can't wait to see you guys again. And thank you for paying attention, and I hope you guys have a great day.